So the first half of this unit focused primarily on identifying the three types of a quadratic function: standard form, vertex form, intercept form, and then looking at how to graph it, how to analyze the graphs, how to interpret their graphs. Now we're going to shift gears and look at solving a quadratic equation, which there are four ways to solve a quadratic equation: square roots, factoring, completing the square, quadratic formula. Those are the four main ways to solve a quadratic equation. Now, the setup of the problem is going to dictate in many ways how you solve it, but any of these four ways can be used. So when you have a quiz or a test or your final next month, when it asks you to solve a quadratic equation, unless it specifically tells you to use a particular method, you pretty much have freedom to do whatever you want. Solve it in whichever way you want. So we're going to look at each of the four types, give it its own attention, work problems associated with each of the four types. So let's go ahead and start with the square roots. So just to give a brief reminder, if you have a square root, to simplify a square root, if it's a perfect square, take the perfect square and be done with it. So square root of 49, 7. Square root of 144, 12. Take the square root and be done with the problem. If it's not a perfect square, that means you have to break it down using perfect squares. So for example, the square root of 20 is not a perfect square. That's equal to 4.47. That's not allowed as an answer. The only time that would be allowed for an answer would be if you were solving out word problems, which we'll get to eventually. But break down the square root. Break it down into two numbers, one of them being a perfect square, and then you take the square root of the two numbers. So we always go about the process of simplifying the square root. If you give a decimal answer, just go ahead and mark the problem wrong. Because you're specifically being told, leave it in its exact format. Now, if you left it as a decimal because you don't know how to break down the square root, that's called, you got plenty of opportunities to come in and ask for extra help. You don't get to do it your way because you don't know how to do it the right way. So make sure you ask. That being said, we're going to do a few examples of solving using square roots. What I will make sure to do on Google Classroom is I will go back and post the notes from when we actually simplified using square roots earlier this year, for those people who need the refresher. So, example 1, y squared equals 64. So the only real opportunity that you have to use a square root is when you have a variable, raised to the second power, or if you have something in parentheses raised to the second power. That's really the only opportunity that you have to use square roots. So, if we look at y squared equals 64, there's nothing in front of it, there's nothing behind it, so we can go right ahead and take the square root of both sides. So y is equal to the square root of 64 is 8. However, There is another number that will give me 64 if I square it, and that's negative 8. 8 to the second power is 64, negative 8 to the second power is 64. So both of those are my answer. So to make sure I indicate that, you use the symbol plus or minus. So you do have to include plus or minus when you give your answer. So if you don't put plus or minus, then you're only giving one answer, which is wrong. So example 1, fairly basic example. Example 2, we add a little bit more to it. 2x squared minus 7 equals 33. So we need x squared completely by itself. We need x squared completely by itself. So that means 7 has to go. So x squared equals 40. And then the 2 has to go. 2 is being multiplied, so we divide to get rid of it. Now the problem is set up for us to go ahead and take the square root. So the square root of x squared, that's simple enough. That's x equals plus or minus. 20 is not a perfect square, so you have to break it down. 20 breaks up into 4 times 5. That's 2 square root of 5. So, notice the setup. Notice how the answer was written. The perfect square goes outside the square root. The number that didn't break down anymore stays underneath the square root. Make sure you write it the correct way. The order does matter. Questions, examples 1 or 2. Again, if you have a question, don't be stuck on stuck. Close them out and open the head. Alright. Okay, example 3. So example 3, though. Problems that are in gray are simply reminders of how you break down square roots in case you needed it. Example 3. 9z squared minus 4 equals 12. So pretty much the same rules apply. The 4's got to go. 9z squared equals 16. Add 4 to both sides. The 9 has to go. Z squared equals 16 over 9. You're still taking the square root of both sides. So we take the square root of a fraction. Both of those so happen to be perfect squares. That's plus or minus 4 over 3. The square root of 16 is 4. The square root of 9 is 3. That's it, problem over. So again, earlier in the year when we worked with square roots of fractions, if both of the top and the bottom are perfect squares, work them out individually, then give your answer. Later on, we will deal with square roots that aren't perfect, especially at the bottom of the fraction. But that will definitely come later. Alright, example 4. So if you notice with example 4, you have a parentheses in the problem. So I'm first going to show you what you don't do. Here's what you don't do. I'm putting it in a different color so that you don't do. So do not take this problem and write it as w minus 6, w minus 6 equals 27, because there's no way you're going to take the square root of that. So this is a situation in which you are not going to write it twice. You're not going to write this twice. Instead, this is a problem in which you can immediately go and take the square root. You can take the square root of a binomial if it's raised to the second power. So the square and the square root, they're going to drop out, so you have w minus 6 equals plus or minus. The square root of 27 is not perfect. Figure out what it breaks up to. So this is where we're at so far. Any questions before we continue? Alright, send your hearing, and I'm hoping that those of you that would be stuck would say something. Let's keep going. W minus 6 equals plus or minus 3 square root 3. W is still not by itself, so we still need to get it by itself. And you add 6 to both sides. So you wind up with W equals 6 plus or minus 3 square root 3. Now, certain books will write it differently. Some books will write it as plus or minus 3 square root 3 plus 6. I personally don't have a preference. So if you give it either way, that's fine with me. The main thing is the plus or minus has to be in front of 3 square root of 3. So be very careful with how you give your final answer. So that wraps up square roots. Questions on square roots before we switch to factoring? All right, we got 1 who said no, that they were good, so we'll move on. So people who, if you have a question, you know how to get it answered. Alright, so we look very briefly at square roots. So now we're going to switch to factoring. So factoring of the four types is going to get used probably more than any of the others. If you think about the four types, you're going to use factoring, quadratic formula, and square roots more than you will completing the square. Completing the square has a purpose, but it's very, very specific when it would be used. So, factoring. To solve by factoring, you're taking something that's in standard form and you're factoring it. So it's an application of what's called the zero product problem. So if you have two things, two expressions set equal to zero, then you can split the two expressions apart. So in this case, x plus 3 times x minus 5 is equal to 0. Then either x plus 3 has to equal 0, or x minus 5 has to equal 0. One of those two has to be 0. So then you would solve it and figure out what it is. Case in point, with example 1, we got x minus 6 times 3x plus 1 equals 0. So take each factor, set it equal to 0. So you have one answer, x equals 6, and you have one answer, x equals negative 1/3. Put the word underneath there, just in case someone wants to know where it came from. So separate it into its two individual equations, and then solve it out. Again, at the honors level, you should be able to easily navigate from a two-step equation down to the final answer. Those would be the level of equation in which you could get away with just one equation to answer. Anything above 2 steps, I expect to see your steps. Anywho, example 2. 3x squared plus 9x equals 0. So now we go back to our rules for factoring. So the first rule of all factoring is greatest common factor. So we check the problem, we see if there's a greatest common factor. In this case, you can take out 3x from both. So 3x parentheses x plus 3 equals 0. So the equation was equal to 0. It's factored. Break it up into its two parts. X equals 0. X equals 3. That's it. Problem's over. Questions, example 1 and 2. seen your hearing aid, so let's look at examples 3 and 4. So 3 and 4, problems get a little bit bigger. So remember, the first step for factoring is greatest common factor. But greatest common factor doesn't work, then remember you look to see how many terms do you have. 2 terms, 3 terms, 4 terms. So if you had 2 terms, that's either difference of 2 squares, sum of cubes, difference of cubes. So my hope is that you didn't throw away your notes from the first 3 weeks of the school year. 3 terms, that's an MAF problem. 4 terms, it's grouping. So, for example 3, m squared minus 17m plus 72, there's no greatest common factor. So we had 3 terms, that's MAF. So the m, first and last number, 72. A is the middle number, negative 17. So we need 2 numbers that multiply to 72 and add up to negative 17. What do we use? Turn y'all factoring brains back on.
Negative 9, negative 8.
That sounds beautiful. Negative 9, negative 8. The leading coefficient is 1, so you would be dividing these by 1, but that doesn't change anything. N minus 9, N minus 8, equals 0. So now that it's factored, separated into its 2 factors. M equals 9. That's it, problem done. So again, with the examples, I'm also showing you roughly what's expected of you in terms of showing your work. Looking at some of the quizzes as they were coming in, and looking at some of the homework problems, homework assignments. Some of y'all aren't showing your work. Guess what? You don't show your work, I don't have to give you credit. I will whole time give you a 0, even if you get every last problem and you don't show any work. How do I know that you did it? So, show every last bit of work. Questions before we go to example 4? Get rid of the little factoring diagram here. Then fix this. Alright, so example 4. 3x squared plus 13x equals 3x plus 8. So this is the first time in which we now get an equation that's not equal to 0. We've got to get the equation equal to 0. We cannot start this problem. We do not start the problem if we're trying to factor it until the equation is equal to 0. So before we do anything, the equation's got to be equal to 0. So 3x has to move, and the 8 has to move. So if we move all those over, 3x squared plus 10x minus 8 equals 0. So just as a side note for you yourself, must get equation equal to 0 first. That's definitely for factoring and for using the quadratic formula. Square roots, you don't need it equal to 0. Completing a square, you don't need it equal to 0. So, get the equation equal to 0 first. So now we factor. We have 3 terms, still use MAF. 3 times 8 is negative 24. We need to add up 10. So we need 2 numbers that multiply to negative 24, add up to 10. What are we using?
-2
Negative 2 is
or
negative 12.
-2.
You had it right the first time. Negative 2 plus 12, if you add it, gives you positive 10. Negative 2 times 12 is negative 24. That's the winning combination. Remember, when you all factor using MAF, there's only one way that the problem can work. There's only one way the 2 sets of numbers can be organized. Your first number was 3. Divide by 3. So negative 2 over 3 doesn't reduce. You have x minus 2/3. 12 divided by 3 is 4. That's x plus 4. So of course, in factoring, we don't want the fraction to be there. So take the 3, move it in front. Now check. Questions before we continue? Well, that's factored. It's equal to 0. Set are equal to 0. So x equals 2/3. X equals negative 4. Any questions, examples 3 or 4? Alright, so we'll finish with example 5. Examples 5 and 6 both work the same way. So we'll do example 5, and then example 6 I'll finish before I post the notes. So example 5. You have 3x minus 2 times 3x plus 2 equals 45. So before you start this problem, you've got to multiply out the left-hand side. So these two have to be multiplied. That 45 can't move yet. That's fine. We do FOIL. That gives you 9x squared minus 4 equals 5. So, since the middle term dropped out, this now gives us two different ways to solve this problem. We could technically solve this using square roots. So if you solve it using square roots, that's 9x squared equals 49. Add 4 to both sides. Divide by 9. And then take the square root. So x equals plus or minus 7 over 3. So that's one way to do it. So if you do FOIL correctly, the 6x and the negative 6x should have dropped out. If you multiply that out, that's 9x squared plus 6x minus 6x minus 4. Those are dropping out. So that's the square root way. Factor it. If you factor that problem, then you got to get it equal to 0. 45 goes over. 9x squared minus 49 equals 0. So to factor it, you have two terms. That's difference of two squares. Well, you see if difference of two squares will work. 9 is a perfect square. That's 3x and 3x. 49 is a perfect square too. Positive 7, negative 7. So this is the difference of two squares. Break them into two equations. And you get the exact same two answers. So we solved the same problem two different ways. Some problems will allow you to do it that way. So example 6, once it's done and put on Google Classroom, you'll see that the only way that's going to work is by factoring it. But that's where all. So again, example 5 is a special case in which, because that middle term dropped out, it allows you to either solve it using square roots or factoring. Example 6 is the type of problem in which there really is only one way to solve it, and that will be by factoring. So example 6, y plus 2, parentheses 3y minus 4. You still have to distribute the distributive property or FOIL, whichever one you prefer. So by doing that, you get 3y squared plus 2y minus 8 equals 100. So again, that comes from performing FOIL. Now notice this time, you have a middle term in 2y. That's not what happened in example 5. The middle term dropped out. So since there's now a middle term, you must, in fact, there is no way around it at this point. So if we're going to factor, the first thing that has to happen is move that 100 over. 3y squared plus 2y minus 108 equals 0. We subtracted 108 on both sides. That's how that happened. So it's still an MAF problem. So since it's still an MAF problem, we need two numbers that are going to multiply so 3 times negative 108 gives you 324. 3 times 108 is negative 324. And adds up to a positive 2. So it's multiply negative 324 and add up to a positive 2. So we look to see, is there two numbers that will allow us to do that? Which, fortunately, in this case, doesn't exist. So this would be a problem in which quadratic formula would now come in, take over. And why are we using quadratic formula? Because you can't factor. Or at least we're not able to factor because we can't find two numbers. And that's okay. So, quadratic formula is something that will come into play fairly shortly in our study of solving quadratic equations. Nonetheless, this is where we're going to stop with regards to solving by square roots and solving by factoring. When we pick up on this again, we'll look at some of the applications that go with solving a quadratic equation using its answers. So with that, have a great day and ask questions if you have them.